On here now to explain to you something called the ambiguous case. And this is an interesting situation that can come up using the sine law. Something you didn't talk about in grade 10, but it involves what we were doing yesterday, Thursday afternoon, solving for angles. And so here's a typical sine law problem where you're given two sides and given one angle and you'd like to find another angle. So I did one possible sketch of this problem here, and so I can start to solve. So of course I will do sine C, write that down first because that's the thing I'm looking for, divided by C equals sine, and I'm looking for my known pair, so I know angle B and side B. Now I can plug in my values. Side C is 11. And side B is 7. And now I can solve for angle C. So multiply both sides by 11 and then take the inverse sine. So C equals sine inverse of sine of 25 over 7 times 11. Okay, and we do that on our calculator and we'll get an answer. So using my calculator, we found, hopefully you found as well, that this was equal to 42. Great, I have my answer. But wait a minute. Think back to Thursday's class. Is this the only possible solution? If you're finding an unknown angle given a ratio, which is exactly what we have here, right? We have a ratio. Is it special? No. So we use our calculator. What's the next step? That's right. I hope someone said it. We have to draw it. So if I draw this, now of course I'm working in degrees instead of radians as we did on Thursday, but this 42 degrees would clearly be in this first quadrant here. So what quadrant would the other answer be in? Its sine is positive, so it would also be in the second quadrant. So not only are we looking for this angle, which we've already found directly with our calculator, but we need to write down the second answer. So the first possibility for C is 42 degrees, and the other possibility would be pi minus, or sorry, we're working in degrees, so it would be 180 minus 42. Right? Which would be approximately 138. So what we have here is we can see that there are two solutions to this triangle. The solution that I have pictured here, where C is an acute angle of 42, but there's another solution, and that is where C is actually an obtuse angle of 138. Let's have a look at what that could look like. That other triangle look like? Well, it could look like this. So notice here we still have an angle of 25 degrees for B, and we still have 7 and 11, but now this angle here, the angle C, is now an obtuse angle. So there are some cases, like particularly if a diagram is not drawn and you can't tell if it's an acute or an obtuse triangle, that there may be two different solutions. So here's a question. Is there an ambiguous case with the cosine law? Think about that. When you solve the cosine law, your calculator always gives you an acute angle. Let's draw it. With cosine, right, you get your first angle from the cosine law, and it would be in this quadrant. Where else is cosine positive? It's positive where the x value is positive, so positive in the fourth quadrant. So there would be two answers for the cosine law. This one and that one. So while there are two answers for the angle you could find using the cosine law, only this angle makes sense because you can't have an angle in a triangle like this. Why? Because a whole triangle only has interior angles of 180, so obviously one of the angles cannot have an angle of over 180. So there is no ambiguous case with the cosine law, only with the sine law, because you can have an answer in the first or the second quadrant. You can have an acute triangle or an obtuse triangle. So you just have to watch out for this when you're solving problems, because the problem might not necessarily come out and say, hey, what are the two possible answers, or this is the ambiguous case. Sometimes they do, but particularly on an exam they might not. So just really pay attention and think about that. And have a great day.